Okay, dokes. The following set of examples are a little bit more complicated, but the rules are the same. So we, of course, need to isolate x. So we need to go add 1 for all three of these expressions. So we add 1 here, add 1, add 1, because we want to get rid of the 1. So we say minus 2 plus 1 is less than x minus 1 plus 1, which is less than or equal to 2 plus 1. Okay, so this will be minus 1 less than x, which is less than or equal to 3. That is our solution set. So let's talk about it again. This minus 1 was in the way, so we added 1 everywhere. On the left, on the right, and in the middle. So the solution to this inequality are all the x values greater than minus 1 but less than or equal to 3. And so when we draw our number line, which I'm going to try and draw nicely, we include minus 1, we have 3, and minus 1 is not included, 3 is included, and so our solution are all the real values between these boundaries. And there you go. Okay, between minus 1 and 3, these are the x values that satisfy the inequality mentioned above. Let's look at the second one. If we look at where x is positioned, the positive 3 is our first problem, and the minus 2 is our second problem. So for us to get rid of that, we are going to subtract 3 over here, and over here, and over there. Right, so we will write it as follows. Minus 1 minus 3. Of course, we get rid of it in the middle, so we just left with minus 2x less than 1 minus 3. We simplify to minus 4, which is less than or equal to minus 2x, which is less than minus 2. Our last step is to remove or get rid of the minus 2, so we divide everything by minus 2. Now remember, I said to you, as soon as you start doing anything with minuses, you go ahead and you change your directions immediately. So this looks like that. Okay, now we continue to solve it. Minus 2x over minus 2, minus 2 over minus 2. So this is positive 2x and 1. Okay, so x is greater than 1 but less than 2. So let's just flip this so that it looks like what we know. So x greater than 1 but less than or equal to 2. Okay, this is what we are used to. So we place the 1 first and we flip the inequality, right? But it still means the same thing because x is still bigger than 1, x is bigger than 1. Okay, x is less than 2, x is still less than or equal to 2. And so on our number line, the values that are important here would be 1 and 2. As we can see, 1 is excluded, 2 is included, and so our number line should look like this. Right, so all the x values that are greater than 1 but less than or equal to 2 will satisfy this inequality.